Welcome guys. In this video we are going to look at two questions from section B of science paper 2 for the 2023 for the internals. So question 1 reads, the following data was obtained from 3 bottles A, B and C suspected to contain a fruit juice, vinegar and ammonium hydroxide. So according to the information that we have, these are just the approximate pH. So number one, we need to look at the pH scale. So the pH scale is just a quantitative measure of the acidity or basicity of the aqueous or other liquid solution. What do we mean by this? The pH scale contains numbers from 0 up to 14. Now the 7 here indicates the neutral solution. Then starting from 7 going to the left shows the acidity, and the acidity of a solution increases as we start from 7 going to the left, then 7 going to the right, the basicity of a solution increases. So from the information that we have here, 11.7 is the basic solution. So this is a basic solution, and it is at least more basic, or we can say it's a strong base that we are dealing with. Then if you look at 7.2, 7.2 is almost neutral. We can say slightly basic, because we've started going up. Then 5.0, this is slightly acidic. So that is the data that we have from the data that was collected. Now question A, which of the bottles contained the first one, fruit juice? So fruit juice has a weak acid, so we are expected to have the pH at least of that of a weak acid. Now the fruit juice has an approximate range of the pH from 2.0 to 4.5. So the nearest number to 5, to 4.5 is 5. So a fruit juice must contain solution C, that is the pH. Then Roman number 2, ammonium hydroxide. So ammonium hydroxide is at least a strong base. So the number that we can see with a strong base is 11.7, which is A. So we have A. Then if you look at the vinegar, vinegar is at least an acidic solution, and if you look at the pH for vinegar, is between 2 to 3. So according to the information, we don't have the information that is coinciding with the vinegar, because this is more acidic than the fruit juice, and 7.2 is not closer to 2.3, but let's just try to just go with B. But with B, I'm not happy with this question. Maybe I can hear from you guys in the comment section below what you think of this one. Now we move on to question B. The contents of bottles A. Remember, if you look at A is 11.7, which is basic. So A is basic, or we can say consists of a base. Then C is slightly acidic, so let's just say acidic, where mixed. Then Roman number 1 is identify the type of reaction that occurred between solution A and C. Type of reaction is acid-base reaction. Then for Roman number 2, describe what would you do to find out if the reaction is exothermic. So exo simply means heat is given out. So exothermic, energy is given out, or endothermic, where energy is taken in nature. Now, how do you determine if the reaction is exo or endothermic? So you just have to look at the rise or drop in temperature. So during the reaction, if there is a rise in temperature, it simply means that heat is given out. Therefore, such a reaction is exothermic reaction. But the reverse, if there is a drop in temperature, then heat is absorbed, and that reaction is called endothermic uh, reaction. So say, just observe the change in temperature. So just observe the change in temperature. Rise in temperature, exothermic. Drop in temperature, endothermic reaction. Move on to question B2. So under question B2, hydrogen gas can be produced on a large scale by reacting methane and steam in a process called steam reforming, as shown in the equation. Now, if we look at this equation, we are given a balanced chemical equation. Now, sometimes you may be just given a statement. So if you are given a statement, step number 1, construct a balanced chemical equation. So if you just miss out on balancing the chemical equation, then whatever that you are going to do will be wrong. So these are calculations from a concept that depends on how well the equation is balanced. Right? So question A. Given that 120 decimeter cubed of methane reacted, calculate the volume of hydrogen gas that was produced at room temperature and pressure. Right? So here we are going to use the law known as Avogadro's, where we use the volume of one gas to find the volume of another gas. And the formula is, we say N1 over V1 is equal to N2 over V2. If you want, we can say V1 over N1 is equal to V2 over N2. It's the same. So the V1, or the initial, we consider for the one that we are given. Then the volume of hydrogen we consider as our final volume, which is the V2 and N2. Now, in our case, we don't have the number of moles for methane and hydrogen. So what can we use? In this way, you are supposed to identify the mole ratio. So what is the mole ratio? The mole ratio is the number in front of, say, an element or a compound. In our case, we are dealing with compounds. So I'm going to begin with the gas whose volume is given. So 120 cubic decimeters is for methane. What is the mole ratio for methane? Since we are not given, it means there is a 1 here. So where there is N, we're going to put 1 divided by the volume is given. So divided by 120 decimeter cubed. And remember, number of moles is directly proportional to volume. So if the volume increases, the number of moles must also increase. So that's a relationship in case you are asked to state that. Then N2, the mole ratio for hydrogen, the number in front of hydrogen is 3. So I'm going to put 3 over, then volume for hydrogen is what we are finding. So I'll just say V2. Then I'm going to cross multiply. So 1 times V2 is just V2. So 120 divided by 3, I'm going to get 360 decimeter cubed. So that's our volume of hydrogen that was produced under RTP. For this one, you don't have to use the formula of number of moles is equal to volume over molar volume. For this to work out, we need the number of moles. Now we don't have the number of moles, so let's use it. This law. Then For question B, hydrogen is used in the Haber process to produce ammonia, which is used to make ammonium fertilizers. Eutrophication is one of the bad effects of using ammonium fertilizers on the environment. Explain what happens during eutrophication. So during eutrophication, we say a body of water. So a body of water becomes enriched, in dissolved in nutrients. That stimulates the growth of aquatic plants and animals. So what happens during eutrophication is, let me see if I can make, so we say we have a body of water. This is a body of water. Then we know that we have aquatic plants that grows in water. Then we also have aquatic animals that lives in water. So if we look at eutrophication, we are looking at where, if somewhere here we have a field, and during the growing of crops, they over applied of fertilizers. So after rains, the rains may wash the fertilizers into the water body. So these fertilizers, which is the ammonium, will cause the water to become, we can say, to become enriched with nutrients. Because of that, there will be overproduction or overgrowth of aquatic plants and animals. Because of that, we may have plants, living organisms like algae, so they will live on top here because there's too much nutrients. So because of that, sunlight will not penetrate through these organisms, and without sunlight, the plants underwater will not survive, they will die out. And because of that, the organisms that lives in water will have no food and oxygen to depend on, because the producers will die out. So that is the picture I'm trying to create on eutrophication. So it's a negative impact that becomes because of over applying of ammonium fertilizers. Then Roman number 2, suggest one way of minimizing eutrophication. So we can say by reducing use of fertilizers, or maybe at least by using the organic matters. So that's one way in which we can look at this. So for online tuitions, please feel free to inbox in the comment section below, like the video, comment and share. So that's it for this video. Thanks for watching.